Hi, today we're talking about algebraic representations of dilations. In other words, what do dilations look like with the letters? Here's what you really need to know. When you have your x and y, the original points, and they're dilated, they're going to get multiplied by a scale factor, and we're going to call the scale factor k. And k is going to multiply with both of your coordinates, and it's got to be the same letter to make a true dilation. So everybody say scale factors multiply. Ready, set, go. Scale factors multiply. Our original times the scale factor equals the new coordinates. When your scale factor is greater than 1, you're going to get an enlargement. And when your scale factor is less than 1, you're going to get a reduction. I'm going to show you what that means. Look at this example. We start out with a really small triangle, and then it dilates into this larger triangle. This scale factor was 2. Every single point of x and y got multiplied by 2. If it had gone the other way and we had started out with this big triangle and it got dilated into this small triangle, then our scale factor would have been 1/2, and we would have multiplied each x and y by 1/2, creating a smaller but exactly the same similar figure. When scale factors are greater than 1, for instance 4, you're going to have a larger shape in the end after dilation. When your scale factor is less than 1, for example 1/5, you're going to have a smaller figure at the end of your dilation. In example 1, we're going to graph the image of triangle ABC after a dilation with the origin as its center and a scale factor of 3. What are the vertices of the image? Triangle ABC's x and y's are all going to get multiplied by 3 to become triangle A prime, B prime, C prime. A used to be at 1, 1, B used to be at 3, 1, and C used to be at 1, 3. But when they undergo the transformation of multiplying by 3 to each coordinate, A prime becomes 1 times 3, comma 1 times 3, which is 3, 3. B prime becomes 3 times 3 and 1 times 3, which is 9, 3. And C prime becomes 1 times 3, 3 times 3, which is 3, 9. The vertices of the dilated image are A prime 3, 3, B prime 9, 3, and C prime 3, 9. Remember, when your scale factor is greater than 1, then it's going to be, we're going to get much larger. Remember to always label your new points, and always make sure that when you connect your new points with your old points, they should all come and meet at the same place. That's a way to check and make sure you did your scale factor correctly and graphed correctly. And always remember that the original times the scale factor equals the new. You dilate by multiplying. Please remember that you must label your new figure with prime notation. Pause. It's your turn to try the next one. We're asked to graph the image of triangle XYZ after a dilation with a scale factor of 1/3 and the origin as its center. Then we're going to write an algebraic rule to describe the dilation. Our points originally started with x at 3, 3, y at 9, 9, and z at 3, 9. Each one of these is going to be multiplied by 1/3. When I put this in the calculator, I literally put in 3 times 1 divided by 3. And then on the y prime, 9 times 1 divided by 3. That will get you the correct answer. Did you end up with 1, 1 for x prime, 3, 3 for y prime, and 1, 3 for z prime? And did you put them on and label the prime with prime notation? And look, isn't that a cute little baby triangle that we just created? Algebraically, what we did was we took every x and y and dilated it by a scale factor of 1/3 to every x and 1/3 to every y. Remember, scale factors multiply. Don't forget that when you dilate, you create similar figures, which means that the sides are proportional. Bonus feature, real quick. What's the difference between a translation and a dilation? Dilations change by multiplication and translations change by addition and subtractions. Thanks for listening. I really do appreciate your attention.